Good evening. So let's discuss some numericals. In a normal Zeeman effect experiment using a magnetic field B of 0.3 Tesla, the splitting between the components of 600 nanometer spectral line is, we have to find out the spectral line. And magnetic field is given and wavelength is given. So we know delta equal to H plus 1 2m MLB, or it can also be written as this is mu B, delta equal to ML mu B. This is for normal Zeeman effect when B is applied, and mu B is Bohr magneton 9.27 10 to minus 24 joule per Tesla. So how we will calculate splitting between two successive levels? So delta equal to mu B into B, and delta is minus SC upon lambda square into delta lambda, which will be equal to mu B into B. So from here we can calculate delta lambda equal to lambda square by SC into mu B into B. Just put lambda, value of lambda 6000 and H value 20 by 3 6.64 10 to the power 34 3 into 10 to the power 8, and put the value of B and mu B, and when you solve it you are getting 0.5 per Tesla. So from here we have calculated the spectral line splitting between the components of spectral lines. So we have given B and we have given lambda, and we have find out delta lambda splitting. Okay, and we have obtained the value. This should be the formula. This should be formula remembered to you, means E equal to mu B, and from here you have calculated delta lambda equal to lambda square upon SC mu B into B. So now onwards we'll go forward. The number of normal Zeeman splitting components of 1p to 1d transition is. So from 1p to 1d we'll go, and we have to calculate number of normal Zeeman splitting components. So we know that Zeeman components in normal splitting is 3 always. Now get Dosha Thera and 2018 question. In a normal Zeeman effect experiment, spectral splitting of the line at the wavelength 643.8 nanometer wavelength is given to us, corresponding to transition 1d2 to 1p1 of cadmium atom, is to observe the spectrometer resolution is 0.01 meter. So we have given the spectral resolution. Okay, means delta lambda is given to us. The spectral resolution is minimum magnetic field. We have to calculate the B. So again delta equal to ZL ml mu B into B. Lambda factor is 1 for orbital or normal Zeeman effect. We have calculated delta equal to SC upon lambda square delta lambda, which will be equal to mu B into B here. So B minimum, from here we have calculated the formula SC upon lambda square delta lambda upon mu B. You have to just remind this formula and you will able to calculate most of the question with this pattern. Just put H, C, delta lambda, lambda square and mu B value, and when you solve it the approximate value you will get is 0.52 Tesla. Now anomalous Zeeman effect. So far so good. So far we have studied normal Zeeman effect. Now we will go for anomalous Zeeman effect. Now when magnetic field is very weak, in this condition, if magnetic field is weak, and so spin orbital coupling takes place first, and total angular momentum quantum number J will interact with B external. Okay, so what is happening here is weak magnetic field is applied, so spin orbital coupling will take place. So magnetic field will interact with total angular momentum, in which L is there and S is there. Okay, now in normal Zeeman effect, what is normal Zeeman? It is the special case of anomalous Zeeman effect. So first we have anomalous Zeeman effect, and the special case of anomalous Zeeman effect is normal Zeeman effect. Each energy level is anomalous Zeeman effect splits into 2j plus 1. How many components? 2j plus 1 components. Got my point? In presence of external weak P. Remember, here magnetic field is weak as compared to normal Zeeman effect. Got my point? Now let's move forward. Delta equal to EH upon 4 by m B into ml, EH plus upon 2m B into ml. So delta equal to ZL ml B into mu B. here delta equal to gj mj mu b into b, and we have know this formula. Now we are studying this formula for anomalous Riemann effect. So we will take, instead of L, we will consider about the total angular momentum quantum number j. And what is mu j? Magnetic moment with respect to total quantum number, L plus s, spin plus orbital. So delta equal to, instead of mu b dot b, here mu j dot b, and z component of this will be this, and mu j z, what will be there? Look at this diagram. This is the z direction, this is the j. Now it should be visible to you. Okay, now let's discuss. This is the total angular momentum j, and the projection of this in this z direction is theta, and in the same direction with j there is a certain angle, there is orbital momentum number L, and orbital angular moment, spin orbital momentum with s. So this is the orientation of j l s with respect to the z. Hope you got it. Okay, now so what will be the z component? So mu l z plus mu s z. So mu j z will be mu l cos l dot z, mu s cos s dot j. So l dot j and s dot j. So cos lj from here, how will you calculate? We'll calculate from here. Simple vector. So cos theta will be s square minus j square minus l square. Sorry, j square plus l square minus s square divided by l dot j. Got my point? And s dot j is same for this. Okay. So from s dot j, j square plus s square minus ka l square into s dot l. And where L square equal to L plus 1 h square, S square is equal to SS plus 1 h square, and J square equal to JJ plus 1 h square. So total magnetic moment J will be minus GJ E upon 2m into J, where this is the Lambda spin factor. For orbital it is 1, for spin it will be 2. So for orbital 1, for spin it will be 2. So the total GJ will be very important formula, you should remember it. Okay, 1 plus jj plus 1 plus ss plus 1 minus ll plus 1 equal to upon 2j j plus 1. Many questions we will discuss this about. And what is the selection rule for anomalous Riemann effect? Why mj equal to 0 plus minus 1 and j to 0 transition is not allowed. Delta j should be 0 and delta mj equal to 0, which is equal to pi component, and delta mj equal to plus minus 1, which will be correspond to sigma component. Got my point? Now sodium doublet. Let's discuss. 2p 3 by 2 to 2s 1 by 2 and 2p 1 by 2 to 2s 1 by 2. So what is D1 D2 line for sodium? This is the D1 line, which is higher wavelength and lower energy, and it is for higher energy D2 line and lower wavelength. So just remember this. There are two spectral lines for sodium doublet. Which are those? First remember P and S. It will be going P and S. S is same, 2 is same, and P3 by 2 to P1 by 2. Got my point or not? Now there is a trick also. Here 1 by 2, 1 by 2. So energy difference will be less. So wavelength will be high. So it will be D1 line. Here energy difference is high. So it will be D2 line. And energy difference is high. So wavelength will be less. So how will you remember sodium doublet? Very short trick. Just remember P and S, P and S, P1 by 2, S1 by 2, P3 by 2, S1 by 2, 2, 2, 2, 2. Got my point? This is the higher energy, so D2. This is the lower energy, so D1. Lower energy, higher wavelength. Higher energy, lower wavelength. Okay? Hope you understand this. So just this is 2s half, 2p half, and 2p 3 by 2. Now check mj and how many components will be 2j plus 1. So it will be in 4, 3 by 2, 1 by 2, minus 1 by 3 by 2. It will be 2, 1 by 2, minus 1 by 2. It will also be 2, 1 by 2, and minus 1 by 2. This is the D1 line. Okay, 1 by 2 to S1 by 2 means which D1 line it is? Lower energy. This for higher energy. When external magnetic field is not applied, final structure are D1 and D2 spectrum is 0. Spectrum given to us as D1 and D2 line. Now check how many transitions are possible. So check this. What is delta mj? 0 and plus minus 1. So let's check. From here to here possible? Minus 1 by 2 plus 1 by 2 0. Yes, possible. From here to here possible? Minus 1 by 2 minus plus 1 by 2 0. Already possible. Now from here to here possible? 1 by 2 minus plus 1 by 2 plus 1 possible. Let's check this. These two are done. Now go to upward. From here to here, is it possible? So 1 by 2 minus 1 by 2 0 possible. From here to here it is possible. Minus 1 by 2 minus 1 by 2 0. Sorry, 1 minus 1 possible. Now this is over. Okay, now let's move forward. From here to here, is it possible? Let's check. So 1 by 2 minus plus 3 by 2, so 4 by 2 equal to 2. So from here to, let's check, minus 1 by 2 minus plus 3 by 2. Now check it. So it will be plus 2 by 2 equal to 1. Yes, it is possible. From here to here is possible. Now let's check. From here to here, is it possible? So 1 by 2 minus plus 1 by 2 0. Yes, it is possible. Now let's check. From here to here, lower possible. Minus 1 by 2 minus plus 1 by 2 0 possible. So all these levels are possible. From here to here, is it possible? 1 by 2 minus plus 3 by 2 is possible. From here to here, is it possible? Minus 1 by 2 minus plus 3 by 2. So it will give to 2 by 2. Yes, 1. So yes, it's this transition is also possible. So these three transitions are possible. Now let's check. From this line, how many times possible? Are these two lines so possible? From here are these two possible? Yes. And from here to here, is it possible? 1 by 2 minus 3 by 2. 1 by 2 minus 3 by 2 equal to minus 2 by 2 minus 1 is possible. Now from here to here, is it possible? Minus 1 by 2 minus 1 by 2 equal to 0. Yes, it is possible. So this line is also possible. So how many lines we are getting? 3 lines and 3 lines. Okay, so these are possible lines. So we are having 6 lines here, 4 lines here. So 4 lines for this and 6 lines for this. So this is anomalous Zeeman effect. So we are obtaining 4 Zeeman components in D1 line. D1 line is P1 by 2. This is the P1 by 2 to 2s1 by 2. And we are having 6 lines in D2 line. So this is D2 line, 2p3 by 2 to 2s1 by 2. So this should be remembered to you that we are having 4 Zeeman component in D1. Okay, and 6 Zeeman component in D2. So we can say in D1 2 sigma plus 2 pi components, 2 sigma components 4 and 2 pi components, and in D2 6 components have 4 sigma and 2 pi. How we are getting this? This सेंट्रल लाइन है ना, जो सेंट्रल वाले हैं वो क्या होंगे? पाई, और जो प्लस माइनस 1 वाले होंगे वो क्या होंगे? सिग्मा. So among these 4, check which were sigma and which were pi. How many sigma and how many pi? Let's check. From this line, minus 1 by 2 minus plus 1 by 2, so 0. So it will be pi. Okay, again check. From this to this, 1 by 2, this also pi. Now let's check this. 1 by 2 minus 1 by 2. Sorry, then this. From here to here, so 1 by 2 minus plus, so this will be plus 1. Okay, so this is sigma. Now this line. So 1 by 2 minus 1, this is 0, this is pi. So sigma, the pi, sigma, pi, and last one is minus 1 by 2 minus 1 by 2 0. So it's also again pi. So thus you can calculate as 0 is central line, which is pi component, and then rest is sigma. Now a spectral line due to transition from an electronic state P to an electronic state S splits into 3 Zeeman lines in the presence of strong B. Strong B means normal Zeeman effect. Intermediate, this was the strong B is for normal Zeeman. So in normal J1 condition, splitting in three components are given to us. But when intermediate field strength B is applied, means inverse Zeeman effect condition में अपने को पूछा है how many spectral lines will be there for inverse Zeeman effect. So transition is happening from P to an S state. So P to S, which is a singlet state. So normal Zeeman effect observed. So we calculate spin part. So only three components will be there. Now when intermediate B is applied, means inverse Zeeman effect is applied. So it will form J. So P and S. So P is L equal to 1, S equal to 1 by 2, and S L equal to 0, S equal to half. So J equal to 1 by 2, 3 by 2, and J equal to half. So it will be split into 1 by 2, same component. It will be split into 2J plus 1, 2 into 1 by 2 plus 1, 2 plus 1, 2 into 1 by 2 plus 1, 1 plus 1, 2 component, which will be P3 by 2 and P1 by 2. So how many components we are having? Final structure we are having 2 plus 1, 3. Now it will be, so this interaction will be, it will interact with B according to J. So P3 by 2, P1 by 2 and S 1 by 2. So how many components will we have? 2J plus 1, 2J plus 1 and 2J plus 1, 4 means total 8 components will be there. Sorry, 8 this and 2 this, okay? 8 and 2, 10, okay? So P3 by 2 to S1 by 2. So sigma and pi will calculate. How many transitions we are having? We are having 6 transitions. How many transitions? 6 transitions we are having. So sigma and pi will calculate how many sigma and how many pi. For formula sigma is 2J2 plus 2J1, and for pi component 2J1 plus 1. So for sigma component 2J2 plus 2J1. So 2J2 is this 2 into J2. So J2 is greater than J1, okay? J2 is greater than J1. So 2J2 plus J1 will be 4, and pi component is 2J1 plus 1 equal to 2 component. 2J2 plus 2J1 equal to 4, and pi is 2J1 plus 2. So 6 and 4 total is 10 components. Got my point or not? So there are certain transitions P3 by 2 to S1 by 2 and P1 by 2 to S1 by 2. So you are having total 10 components. 4 तो 6 2 8 and 2 10. Now the ground state of sodium 11 is 2s1 by 2. We know the reference energy level arising in the presence of weak external magnetic field. So weak means, what does weak means? Anomalous. Just put this. So calculate Gj. 1 plus Jj plus 1, S plus S plus 1 minus LL plus 1 by 2 Jj plus 1, 2s half. So S is 2s plus equal to, so 2s equal to, S equal to half, L equal to 0, J equal to 1 by 2. Just put it here. Calculate Gj to MVP. Now we can do it directly. How we will calculate directly? Just remember this formula. Okay, we have to find out the answer in MUPP. So just calculate Gj. And how will calculate Gj? We know sodium's electronic configuration is 3s1, and all the first group elements have configuration is 3s, 5s, 4s. Okay, so one electron in S, so L equal to 0, J will be S. So we are having pure spin. So pure spin nature Gaj is equal to Gs, which is equal to 2. And you can find out direct answer. Now we'll discuss about pass and back effect. In the Zeeman effect, B external is weak as compared to spin and orbital motion of the valence electron. Okay, Zeeman effect में क्या हो रहा था? एक्सटर्नल जो इलेक्ट्रिक फील्ड है इलेक्ट्रॉन में क्या हो रहा है? वीक हो रहा है. When however the strength of B external increases as we are increasing the B, the separation between Zeeman components increases until they become greater than the separation between the multiple fine structure components. So what we are doing? separation between the components is increasing with respect to b increasing. Now till how much time we will do this? Until they become greater than the separation between multiple fine structure components. Okay, so overall we have to separate the splitting the levels. Separation between the splitting levels should be greater than the separation between multiple fine structure components. This is the point. Now the anomalous pattern change over the normal Zeeman effect. This effect is known as Paschen belt effect. So the anomalous pattern changing over the normal Zeeman effect, okay, which is known as Paschen belt effect. So this is delta L formula, we know this. So delta equal to ml plus 2ms, which is gl equal to 1, gs equal to 2. So just put it here. We have the separation ml plus 2ms L1, which is Lorentz unit in centimeter inverse. This is the expression for strong magnetic field ignoring spin orbital interaction. So in it we are not considering the spin orbital interaction. Each of the field free level is split into 2l plus 1 2s plus 1 energy levels. Section notes are 0 plus 1 and delta m is equal to 0. Here again center is pi, and beside this center sigma components will be there. Now sodium doublet, P3 by 2, S1 by 2, P1 by 2, S1 by 2. This is the T1 line and this is T2 line. PS 1 by 2, 1 by 2, 3 by 2, 1 by 2, higher energy, so T2, lower energy, D1. Lower energy, higher wavelength 5.96, higher energy, lower wavelength 5.90. Clear. Sodium you will never forget. Now let's check it. So this is 2s, this is 2p. Okay, so it will be 2s half, s will not be split, only single, and p will be in 1 2 3 4 5 6 2 1 0 and 0 1 minus 1, 2p 3 by 2 and 2p 1 by 2 basically. ml plus 2ms, ml is 1 minus 1, ms is, from here we can calculate. So we are having the value ml is 1 0 minus 1 1 0 minus 1, and here 0 0 for s, and ms is half half, here minus half, and here 1 by 2 minus half. This is the value of mj. So far so good. We have studied these kind of things. Normal Zeeman effect, delta A GL ml mu bb, 12 plus 1 splitting. Anomalous Zeeman effect, gj mj mu bb, 2j plus 1 splitting. Paschen belt effect, ml plus 2ms mu b into p, ml plus 2ms mu b into b, splitting will be 12 plus 1 2s plus 1. Hyperfine stage will be gf mf mu b into b, 2f plus 1 with nuclear spin. So 2f plus 1, which what is f? It is total angular quantum number, which also include spin angular quantum number, spin quantum number. So find out gj for 2p and 3s electron. So this is the carbon 6 normal. So first excited 2p1 and 3s1. This is the excited state. Now calculate for L1 S1, L2 S2. So L with this S will be this, so J will be 210. So just 2s plus 1 LJ, इलेक्ट्रॉनिक जो अपना है पैटर्न बनेगा वो ये बनेगा, है ना, 2s plus 1 LJ form. So put s equal to 0, singlet 1p1, triplet. So for 3p1 in the question it is given for 3p1, so gj will be 1 plus j plus 1 s plus 1. Put the values and you are having gj equal to 3 by 2. Now we have to calculate level splitting. If now same question, if magnetic field is given to us, we have to calculate the splitting. So we have here delta T equal to minus gj mj L prime, which is L prime is centimeter inverse, L prime is EB by 4 pi mc. So delta T equal to 3 by 2 AB upon 4 pi mc into centimeter inverse. So just put the value and you are having the answer is 0.07 centimeter inverse. Now the ground state configuration of rare ion neodymium plus 3 is assuming LS coupling, G is given to us, the effective magnetic moment in mu b. अपने को मैग्नेटिक मोमेंट निकालना है, टोटल म्यू जे निकालना है. म्यू जे का फॉर्मूला क्या होता है, जी जे अंडर जे जे प्लस 1 म्यू बी. अपने को जी जे कैलकुलेट करना है, जे कैलकुलेट करना है, म्यू बी अपने पास है. सो जस्ट थिंक हियर, we are having 5p6, and we are having LS coupling, and we have L equal to 6 here. Okay, so just 8 1 2 3 4 5 6 7 3 2 1 0 minus 1 1 minus 2, so it will be in 4f3, remember. So 3 electron in 4f, so total will be in 3 to 5 1 6. So L equal to 6, A6 3 by 2 1 by 2 1 by 2 1 by 2. So J will be L minus S 2 L plus S, 6 minus 3 by 2 9 by 2 11 by 2, and 6 plus 3 by 2. So we are having 6 plus 3 by 2 means 15 by 2. So ground state will be half filled 9 by 2. So the 2s plus 1 LJ form will be this. So mu j equal to gj, and do j into j, gj is given to us. Just put j and we're calculating mu b. Very good. Mu j in atom is in singlet state. Singlet means s equal to 0, subject to a b. Jima splitting of valence is given to us, and splitting is also given to us. The b अपने को d भी निकालना. So delta e we know this, and delta equal to 0 mu b into b. Just put the value and put the all do mathematics. You will get 1.57 something answer. So very easy peasy. Just use the simple approximation and you can do it. I know you can do it. I had done this, and you, I am sure if I can do this, anyone can do this. You are the champions. Why settle for less? If you can solve it, solve it. Ground state of chlorine atom is 2p3 by 2. Find his magnetic moment निकालना है ना. सो मुझे लोग पता है क्या चाहिए, अपने को जीजे चाहिए और क्या चाहिए, तो जीजे कैलकुलेट कर लो. 1 प्लस जे इंटू जे प्लस 1 प्लस एस इंटू एस प्लस 1 माइनस एल इंटू एल प्लस 1 बाई 2j इंटू जे प्लस 1. सो जीजे विल बी 4 by 3. Put here, and j is 3 by 2. L equal to 1, s equal to half from here. So mu j by 2.6 mu b. From here we are calculating mu l equal to minus l upon 2 m होता है, यहाँ gl होता है ऑर्बिटल वाला. So l upon 2 में हो जाएगा. And when we put in h cross form l, h cross form to mu b, so this will form, this will be form for orbital. You calculate for total, then gj into mu b. Same, open it, it will be again give you h cross. So if you mu b, this will be formula. Very good. Now we have reached at the point we will forget B for some time, and now we will go for electric field. So in 1930, Stark discovered that the Balmer lines emitted by hydrogen atom placed in electric field of the order of 10 to the power 5 volt per meter are split into number of polarized components. So now what is electric fields? Lines are splitting. So when viewed in perpendicular to the field, some of the components of each line are plane polarized with electric field vector which were parallel to the fields, which is known as pi component, and the other are polarized with electric field vector which is perpendicular to the field, which is known as sigma component. So the electric field which is parallel are known as pi component, electric field which is perpendicular which is known as sigma component. Earlier on, which we were studying the Zeeman effect, pi is center and sigma is plus minus 1. Now pi is parallel. Remember how we write pi this, so this is parallel, and sigma is sigma, this is perpendicular. परपेंडिकुलर ना, गैंग्स ऑफ वसेफर मूवी वाला वही परपेंडिकुलर है ना. सो रिमेंबर स्टार इफेक्ट में परपेंडिकुलर था. स्टार इफेक्ट, एज स्टार इफेक्ट इंक्रीजेस, सो स्टार का पैटर्न क्या होगा, एच एल्फा का स्टार पैटर्न कम होगा इससे एच बीटा से, मीन इंटेंसिटी उनकी क्या होगी ना लाइन्स की. नाउ सिलेक्शन रूल्स फॉर वीक मैग्नेटिक फील्ड सेम एज जीमान है ना. इसमें भी क्या होना चाहिए, वीक मैग्नेटिक फील्ड जीमान होता है इनवर्स जीमान. सो डेल्टा एम जी इक्वल टू 0 पाई कंपोनेंट प्लस माइनस 1 सिग्मा कंपोनेंट, एंड स्ट्रोम में क्या हो जाएगा, एम एल 0 पाई सिग्मा. The transistor of ml plus 1 gives components circularly polarized in opposite sense ना. यहाँ पे ml plus 1 क्या देंगे, circularly polarized देंगे opposite sense में. Now very important, fine stereo components of H alpha have not been completely resolved. The weak field electric field Stark pattern has not been observed. So fine structure में क्या हो रहा है, H alpha के fine structure में वो रिजोल्यूशन नहीं था, इसलिए वीक फील्ड स्टार्क पैटर्न ऑब्जर्व नहीं हो रही थी. द स्टार्क शिफ्ट फॉर द ग्राउंड स्टेट ऑफ हाइड्रोजन एटम इज 0. Now hyperfine structure. Now we'll discuss about hyperfine structure of spectral line. There are two types of the nuclear effect that produces hyperfine structure. सो बोर वाला क्या डिस्कस किया, एन इक्वल टू 1 टू 5 में क्या होता है, एलियस कपलिंग होती है। हाइपरफाइन क्या हो रहा है, न्यूक्लियर स्पिन। ये थोड़ा सा एक पैटर्न ध्यान रखना है ना। बोर में एन इक्वल टू 1 टू 3 हो रहा है, उसमें कोई दिक्कत ही नहीं थी। फाइन में क्या होगा, एलियस हो गया। हाइपरफाइन में न्यूक्लियर स्पिन। नाउ ड्यू टू प्रेजेंस ऑफ डिफरेंट आइसोटोपिक स्पीसीज, है ना, ये आइसोटोप्स हैं इन द एलिमेंट यूज्ड फॉर स्टडी द एनर्जी लेवल्स ऑफ आइसोटोप्स आर स्प्लिटिंग। क्या हो रहा है, आइसोटोप की एनर्जी स्प्लिट हो रही है, स्लाइटली डिस्प्लेस्ड relative to each other, producing spectral transition at slightly different frequencies. So हाइपरफाइन स्ट्रक्चर में क्या हो रहा है कि जो अपने डिफरेंट आइसोटोप्स हैं एक ही एटम के, है ना, एक ही एलिमेंट के, उसके जो एनर्जी लेवल्स हैं वो स्लाइटली डिस्प्लेस कर रहे हैं ना खुद के ईच अदर से ही। तो वो क्या कर रहे हैं, स्पेक्ट्रल लाइन प्रोड्यूस कर रहे हैं विथ स्लाइटली डिफरेंट फ्रीक्वेंसीज। सेकंड टाइप ऑफ इफेक्ट अराइजेज ड्यू टू न्यूक्लियस passes a spin angular momentum and associated magnetic dipole moment. An interaction between the internal magnetic field produced by spin and orbital motion of electron in the atom and the spin angular momentum spin magnetic moment of nucleus causes a hyperfine split. Got it or not? Again read this with me. Now second टाइप में क्या हो रहा है, क्यों अराइज हो रहा है, न्यूक्लियस क्या कर रहा है, पजेस कर रहा है किसको, स्पिन एंगुलर मोमेंटम को। एफ वाला जो अपन काम में ले रहा है आई न्यूक्लियर स्पिन की वजह से, वो भी स्पिन एंगुलर मोमेंटम है जो किससे एसोसिएटेड है, मैग्नेटिक डाइपोल मोमेंट से एसोसिएटेड है। नाउ व्हाट विल हैपन, इंटरेक्शन बिटवीन द जो इंटरनल मैग्नेटिक फील्ड है जो किसकी वजह से, स्पिन ऑर्बिटल मोशन ऑफ इलेक्ट्रॉन जो हो रही है न्यूक्लियस के अंदर उसकी वजह से, सॉरी एटम के अंदर, इन द एटम एंड द स्पिन एंगुलर मोमेंटम। ठीक है, तो एक मैग्नेटिक फील्ड किसकी वजह से है, स्पिन ऑर्बिटल मोशन की वजह से, इलेक्ट्रॉन की वजह से, और एक क्या है, स्पिन एंगुलर मोमेंटम जो स्पिन मैग्नेटिक मूवमेंट है उसकी वजह से न्यूक्लियस के अंदर। ठीक है, सो ऑर्बिटल वाला न्यूक्लियस वाला इंटरेक्शन कर रहे हैं, इस वजह से क्या हो रहा है, हाइपरफाइन स्ट्रक्चर प्रोड्यूस हो रही है। इस न्यूक्लियर मैग्नेटिक डाइपोल मोमेंट आर स्मॉलर देन द electronic magnetic dipole moments by the factor of almost 10 to the minus 3. Hyperfine splitting is smaller than the floating fine state splitting. So what does it mean? We know that the nuclear magnetic dipole moment is very less as compared to the इलेक्ट्रॉनिक मैग्नेटिक डाइपोल मोमेंट है। न्यूक्लियर वाला मैग्नेटिक डाइपोल मोमेंट कम होता है किसके मुकाबले, इलेक्ट्रॉनिक वाले के मुकाबले। किस फैक्टर से, तो हाइपरफाइन स्ट्रक्चर क्या होगी, स्मॉलर होगी, बिल्कुल है ना, क्योंकि जब इंटरेक्शन ही वीक है तो जो स्प्लिटिंग है वो भी स्मॉलर होगी। So we know this, and we know mz square is to power 4 upon 8 epsilon naught h cube c। इसको हम मानते हैं इन्फिनिट हेवी न्यूक्लियस के लिए। अब यहाँ पे देखो क्या करो, न्यूक्लियस वाले के लिए क्या ले लो आप, इन्फिनिट हेवी न्यूक्लियस ले लो। इसको अपन रिप्लेस कर दो किससे, रिड्यूस मास से, किसके, इन्फिनिट हेवी न्यूक्लियस से। तो क्या आएगा, न्यूक्लियस वाला, और जो समाहित द्रव्यमान होता है, रिड्यूस मास होता है, वो दोनों कंपोनेंट से क्या होता है, कम होता है, तो ये लेस देन 1 है, ये में है। सो अपना जो प्रैक्टिकल मास है वो क्या हो जाएगा, म्यू जेड स्क्वायर इज टू 4 अपॉन 8 एप्सिलॉन नॉट स्क्वायर एच क्यूब सी। सो जो अपना एक्चुअल रिटबर्ग कांस्टेंट है वो कम होता है किससे, इन्फिनिट से। मिस लाइटर ये मास पे डिपेंड कर रहा है, ठीक है। सो लाइटर के लिए कम होगा हेवियर से, मीन्स हाइड्रोजन का कम होगा रिड्यूस मास किससे, ड्यूटेरियम से। मीन्स एल्फा का मास किससे कम होगा, ड्यूटेरियम से। मीन्स अब देखो यहाँ से क्या हुआ, जो अपनी जो स्पेक्ट्रल लाइन की फ्रीक्वेंसी थी वो डायरेक्टली प्रोपोर्शनल टू थी किसके, आर के, वो आर किसके डायरेक्टली प्रोपोर्शनल टू एम के, मीन्स म्यू डायरेक्टली प्रोपोर्शनल टू एम। मीन्स हेवियर का ज़्यादा होगा, वो हेवियर का ज़्यादा है लाइटर से, यहाँ भी हेवियर का ज़्यादा है लाइटर से। मीन्स एनर्जी किसकी ज़्यादा होगी, हेवियर की किससे, लाइटर से। और इसी वजह से अपनी जो ड्यूटेरियम है ना उसकी जो खोज हुई थी, ड्यूटेरियम वाज डिस्कवर्ड बिकॉज ऑफ दिस सेम कॉन्सेप्ट। ठीक है, सो फॉर लाइटर आइसोटोप की एनर्जी क्या होगी, कम हो जाएगी किससे, हेवियर से, और वेवलेंथ क्या हो जाएगी, बढ़ जाएगी। नाउ विल डिस्कस अबाउट न्यूक्लियर स्पिन एंड हाइपरफाइन स्प्लिट्स। सो न्यूक्लियर स्पिन एंड हाइपरफाइन स्प्लिटिंग इज गिवन बाय 1924 इन बाय Pauli proposed that hyperfine structure can be explained by taking nuclear spin into account। जो आया उसको एक्सप्लेन करना था ना वो अपने को, तो कैसे एक्सप्लेन करिए उन्होंने, आई क्या मान लिया अपना, न्यूक्लियर एंगुलर मोमेंटम, और आई क्या मानी, मतलब वेक्टर के बिना मानी है तो हमने क्या मानी, न्यूक्लियर एंगुलर मोमेंट क्वांटम नंबर मान ली। सो आई वेक्टर इक्वल टू, मतलब जो अपना एंगुलर मोमेंटम है वो किसके इक्वल, अंडर आई प्लस 1, क्वांटम नंबर क्या पता ही है सबको यार, क्या बता रहा हूँ, एफ इक्वल टू जे प्लस आई। सो एफ इक्वल टू अंडर एफ प्लस 1 एच को, सो एफ क्या है, एल प्लस एस प्लस आई। सो एफ की वैल्यू क्या होगी, j माइनस आई टू जे प्लस आई, है ना। एफ रिलेटेड है जे से, जे रिलेटेड है एल से और एस से, एफ रिलेटेड जे से और आई से, j minus I to j plus I. So f will take 2i plus 1 if I is less than j, और 2j plus 1 जो भी इस्तेमाल होगा ना, और जो अपना म्यू एफ है वो क्या आएगा, 2f plus 1 वैल्यूज ले लेगा। और अपने एनर्जी के बारे में बात करते हैं अब, a प्राइम बाई टू एफ प्लस माइनस आई प्लस वन जे प्लस वन। द वेरियस हाइपरफाइन स्प्लिटिंग लेवल्स ऑफ ए गिवन एटम हैव द सेम आई एन जे बट डिफरेंट एफ। So splitting will be defined as this: a prime f of plus 1. So selection rules will be 0 plus minus 1 and 0 0 is not allowed. Hyperfine splitting of bismuth line is 4722. So there is a question 6p3 to 6p2 7s1. This is the ground state, this is excited state. For ground state 3 electron, so L equal to 0, S equal to 3 by 2, J equal to 3 by 2, F equal to J minus J minus I टू J प्लस I। और यहाँ पे I क्या है, गिवन है अपने को, क्या है I गिवन, I हाँ चलो इसके लिए तो चलो अपन इसको इसमें ले लेते हैं ना, एल माइनस एस टू एल प्लस एस। और यहाँ पे क्या हो जाएगा, एफ इक्वल टू आई प्लस जे, सो इट विल बी 5/4 एंड डेल्टा एफ इक्वल टू 0 प्लस माइनस 1। सो how many lines, 6 lines will be there. I is given to us 9/2, so I minus j to I plus j, here also I minus j to I plus j. So we are having 3 4 5 6 and 5 4, 3 4 5 6 and 5 4. So just make the transition delta f equal to 0 and delta f to plus minus 1. So we are having 6 lines here. Now hyperfine station of sodium D2 line. Sodium D2 line वही P3/2 S1/2. This is D2 line, high energy, lower wavelength, 5 at 90 ms. So J equal to 3/2, J equal to 1/2. So here F equal to 0 1 2 3. Here F equal to 1 and 2. From where you calculate I minus J to I plus J. I minus J to I plus J. So 0 1 2 3, 0 1 2 3, 3/2 will be split and 1/2 will be this. Check splitting 0 plus minus 1. We are having 6 lines, hyperfine components. Rest will be tomorrow. Thank you very much. Please subscribe if you like it.